My name is Mike Dempsey and I'm Managing Director of a small spin-out company called Advanced Bioprocess Development Limited. The company was set up a few years ago to commercialise my research, and the research involves developing biological processes using this expanded bed technology so that we can have more productive processes and more cost-effective processes for a whole variety of things, from water and wastewater treatment through to fermentation and biocatalysis. Here we see the expanded bed biofilm reactor, and this consists of two columns, the left-hand column for aeration and the right-hand column is the expanded bed itself. We'll talk about the aeration system first. Wastewater enters at the top of the aeration column and flows down, whilst at the same time air, or oxygen-rich air, enters at the base of the column and rises up. So in this system we have counter-current flow. That means we get very efficient transfer of the oxygen from the gas phase to the liquid phase. The aerated wastewater is pumped from the base of the aeration column to the base of the expanded bed column. As the aerated wastewater flows up through a bed of porous carbon particles, it imparts a drag force on those particles, lifting them up and separating them and thus expanding the bed. Microorganisms grow on these porous carbon particles to form a biofilm, and that biofilm gives us our biological activity to purify the wastewater. As the bed expands, it continues to fill an increased volume of the expanded bed until it reaches the bioparticle overflow line, where it is drawn automatically back down to the base of the bed and is re-injected. Treated wastewater leaves the top of the bed and goes off to be discharged. Part of that wastewater may be recycled according to the particular flow characteristics of the works at the time. For example, if it's been raining heavily, we may have a single pass system, whereas in dry weather we would recycle at least 3 times through the system. So the advantages of this expanded bed technology are severalfold. Because the cells attach to the support material, then they're not washed out with whatever the liquid is passing through the system. In a wastewater treatment process, that would be the wastewater. In conventional wastewater treatment processes, the cells are washed out, have to be sedimented and then recirculated back to the beginning of the process. Or, in the trickling filter system, for example, the microorganisms are stuck to a support material similar to the expanded bed, but those support materials are much larger. So because we use very small particles of about 1 millimetre in size, we get a very high biomass concentration and a very large surface area of biofilm. So we get about 40 kilograms of biomass per cubic metre of expanded bed, whereas in, say, an activated sludge wastewater treatment process, you would have 2 to 3 kilograms. So we're 20 times higher in biomass concentration.